Hey, it's Dr. J again. I'm here with Anthony. Want to say hi, Anthony?
Hello.
We're going to convert a program that we wrote a while ago to calculate the factorial of a small positive integer. And you guys all remember what factorial is, right? Do you want to tell them what 3 factorial is, Anthony?
3 factorial is you take 3 and multiply it by 1 times 2 and then 3 itself.
Okay, so it's 3 times 2 times 1, or n factorial would be n times n minus 1 times n minus 2 all the way down to times 2 times 1. So we have formula that does this, and the program that we wrote, let's go over the logic of that again. It initializes a variable n, and it asks the user for the input. And then we initialize a variable f to hold the solution, and we initialize it to 1. And then we loop through, beginning with 1, ending with n. We keep multiplying the next digit. So first we multiply by 1, then by 2, then by 3, then by 4, all the way up to n. And let's run this just as a reminder how it looks. Okay, so for small n, you said 3 should be 3 times 2 times 1?
Yes.
All right. That looks good, right?
Yes.
Let's try it with a slightly larger case. 5 factorial would be 5 times 4 times 3 times 2 times 1.
Yep.
120 looks good. Notice also that this we're going to do later, that 5 factorial is 5 times 4 factorial, because 4 factorial is 4 times 3 times 2 times 1. And we can keep that in mind when we learn recursion. Okay, so what we want to do really is an intro to functions. Now, int main is a function, and that's why usually we return zeros. I don't know why this program doesn't, but we're going to say return 0, because the return type is int, right? There are no parameters being passed to main, but for factorial, if we make a function, we're going to need parameters. So I'm going to make a prototype. Int, let's call it fact, int fact, and there's one parameter being passed of type integer. I don't have to give a name to that parameter. This is a prototype. Prototype for the function that calculates factorial. Okay, now we need a prototype if we define the function after main. If we define it before main, we can get away without it. But it's good form to put a prototype, so we're going to. So now let's define the function itself. So again, it returns an int, and the name is fact, and it takes a local variable as a parameter. Let's call it n. Why not? And squiggly line, and now we can go ahead and basically it's the same logic. So I'm just going to cut and paste this logic here. Control X, Control V. So now we have the same 2 lines that we had originally in main as part of our function. You want to read those 2 lines?
For int fact, int n is int f equal 1, and then for n equals 1, I less than equal to n, and I plus plus, f times equal to I.
Okay, so we multiply by 1, and we multiply by 2, 3, 4, all the way up to n, whatever n is. The user is going to tell us n in the main line, and then we're going to pass it to the function. So we need to return the result. That's all that's missing. The return type is int, so we have to be sure we're returning an integer. F should have the result, right? Return the factorial. Okay, so now we still have to ask the user to enter n, and the output will be n factorial and c in n. Only this time, c out factorial is, we need to say fact of n. Fact. The way we call the function is the name of the function, and the parameter is also called n. Now, I don't have to give the same name here that I use here, but this parameter n is different than this parameter n.
Do you use a different variable?
Yes, Nehal, and I'm going to, but first let's run it using the same variable name, just to see if it works. Okay, so let's try the same ones, 3 and 5 later. That's good, right?
Yep.
I'll run it again, and we should get the right result for 5. All right. Now, let's see if in fact it can work with different variable names. So I'm going to call this, instead of n, let's do a replace, Control F, replace n with, no, that's not going to work because it'll replace it in the middle. Let's just one by one replace it. All right, so replace n here with a different name. Let's call it n1. Less than or equal to n1. Okay, so that was simple enough. Now, clearly, this is different parameter than this one. In fact, this n will be passed into the n1. Copy of n is made and sent into n1. Let's try it. Compile and run. All right, so let's try 3 factorial. Still 6. Whoops, I'm getting trigger happy again. Run it. 5 factorial is still 120, looking good. So you see, this is the first function that we've written together in class, factorial function, with the prototype. Now, again, if we didn't want to put a prototype, we could just cut and paste the function, put it in front of main, and get rid of the prototype. So let's get rid of the prototype. And cut and paste the entire function and put it in front of main. This shows that we will not need a prototype if we declare the function and define the function before main. All right, let's run it, compile it. Try 3, 6 again, try 5. It's good. Okay, so this looks pretty good. Any questions from the peanut gallery? So we've written our first function. Now I want you to write a function that calculates the area of a circle and try calling it. So that you're going to do right now for classwork. Thank you, Anthony. You were great, as always. And that's it for today. Dr. J and Anthony saying till we meet again.